In this tutorial, we'll cover structure-based protein design, also called inverse folding, using ProteinMPNN. To run inverse folding, you will need a protein structure in a PDB format. Let's quickly produce a starting structure in 2 steps. First, we'll ask Copilot to find a human IL-21. This searches the UniProt database and brings back the top 5 results. Second, we'll ask Copilot to predict the structure of the second one in the table. This runs ESMFold and returns a prediction within a few seconds and shows it on the right. This new structure is automatically named, in this case P1. So now we can ask Copilot to use ProteinMPNN to design P1 with a temperature of 0.1. Although it's called a temperature, this is a computational parameter and not tied to the physical temperature that the protein is expressed or stable at. Think of it as a knob that you can control, where the higher the temperature, generally, the more mutations are allowed. This temperature ranges from 0 to infinity, but for ProteinMPNN, temperatures above 1.0 typically result in random sampling, so it's suggested to stay well below that. After about 15 seconds, you'll see the newly designed sequence show up in the visualizer in a new layer. While the output of ProteinMPNN is a sequence, Copilot automatically runs a structure prediction and structure alignment in the input, as well as highlight changes compared to the input in red. The score is a measure of the model confidence. In this case, it ranges from 0 to positive infinity, where 0 is the best. You can also run ProteinMPNN by first uploading any PDB file using the paperclip icon. The upload is automatically named. Here, it's named U1. Now we can ask Copilot to use ProteinMPNN to inverse fold U1. Like before, Copilot takes the sequence output of inverse folding, automatically generates a predicted structure, compares both the sequence and structure, and shows all of this in a new layer on the visualizer on the right. We can look back through older results using the layer control on the bottom right of the visualizer or by clicking on older prompts. But we can also ask Copilot to more directly compare P1, P2, and P3. This will automatically try to compare the sequences and structure with P1 as the reference and provide a table of useful metrics. You might notice here that the sequence of the inverse folded proteins are quite different from the original. For ProteinMPNN, having designs sequences with 50% or more of the sequence changed is expected and common. Finally, you can export all to get a link to all of the sequences, PDBs, and logs. Thanks for watching, and see you in the next one.